Sequences. Suppose we drop a ball from a height of 1 meter. It hits the ground and it bounces back up to a height of 1/2 meter. It then hits the ground and bounces back up to a height of 1/4 meter. Each time it reaches the height 1/2 of the previous height. And so the initial height is 1 meter. After the first bounce, the height is 1/2 meter. After the second bounce, the height is 1/4 meter. After the third bounce, the height is 1/8 meters, and so on. In this scenario, we assume that we drop the ball from the initial height of 1 meter. Its height after each bounce is half of its previous height, and we assume that the ball keeps bouncing up and down. Let a sub n be the height of the ball after the nth bounce. So initially, the height a sub 0 is 1. After the first bounce, the height is 1/2, and then a sub 2 is 1/4, a sub 3 is 1/8, a sub 4 is half of 1/8, which is 1/16. We list the heights of the ball in order. They are 1, 1/2, 1/4, 1/8, 1/16, and so on. This is called a sequence. Note that there is a pattern to these numbers. They can be represented by a function f of n equals 1/2 to the n for n equals 0, 1, 2, and so on. And so a sequence is an ordered collection of numbers or objects. They're defined by a function f on a set of sequential integers. A sub n might or might not be represented by a function, but a sub n are the terms of the sequence with the index n. A sequence can be listed at a sub 1, a sub 2, a sub 3, and so on. Since a sequence is a collection of numbers, we use the curly bracket to denote the sequence. We start with the index n equals 1, and we end with infinity. There is nothing special about the letter A or B. For example, the sequences of A start with n equals 100 and end with infinity. These are the infinite sequences. We use the 3 dot symbol to denote that there are infinitely many more numbers to follow. When we work with sequence, n factorial shows up often. N factorial is defined to be the product of all of the integers starting from n ending with 1. 0 factorial is 1. 5 factorial, for example, is 5 times 4 times 3 times 2 times 1, which is 120. For example, write the first 6 terms for the sequence a sub n starting with n equals 1, where a sub n is defined to be 1/n factorial. We start with the index n equals 1. When n equals 1, a sub 1 is 1/1 factorial, which is 1. A sub 2 is 1/2 factorial, 1/2. A sub 3 is 1/3 factorial, 1/6. A sub 4 is 1/4 factorial, 1/124. A sub 5 is 1/120. And a sub 6 is 1/720. A sub n is given by the function 1/n factorial, so to obtain the terms a sub n, we plug in the input n. Another example, the sequence a sub n, where c sub n is pi, and n go from 1 to infinity. The function that represents c sub n is pi, which is a constant function. So a sub 1 is pi, a sub 2 is pi, a sub 3 is pi, a sub n is pi, and so on. This sequence can be listed at pi, 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 and so on. Another example, the sequence d sub n as n go from 3 to infinity, where d sub n is ln of n minus 1 over n minus 2. We start with the index n equals 3. D sub 3 is ln of 2 over 1. D sub 4 is ln of 4 minus 1, which is 3 over 4 minus 2, which is 2. d sub 5 is ln of 4 over 3. d sub 6 is ln of 5 over 4, and so on. Starting with n equals 3, we obtain the first 6 terms. These can be rewritten as ln of 2 minus ln of 1, d sub 4 is ln of 3 minus ln of 2, d sub 8 is ln of 7 minus ln of 6, and so on. In fact, ln of n minus 1 over n minus 2 is ln of n minus 1 minus ln of n minus 2.